Welcome back. Page 308 is where we're at, and it has another place for your name. Name, number, date. While you're finishing that, I'm going to read number 12. The lake's water level rises 10 centimeters each day. Oh, it's a constant rate. For every day, it goes up 10 centimeters. The table shows the total change in water level for 0, 1, 2, and 3 days. Great. In 0 days, the water changed 0 amount. Makes sense. In 1 day, it changed 10 centimeters because, remember, every day goes up by 10. So 2 days is 20, 3 days is 30. What would 7 days be? 70. Okay, I think you get it. So we're going to graph the data in the table. What? How do you graph data in the table? You have to circle corresponding pairs. Corresponding pairs are going to give you your coordinate graphing points. So sweet. It says graph the data. Let's first do that. 0, 0, right on the origin. Make a good bold point. 1, 10. Oh, look how interesting. Do you go over just one line or do you go over to the 1? To the 1. So I go over and up to the 10. Next one is 220. You're going to find a pattern real quick as you're doing this. Okay, graph the data. Connect the points and extend the line. Connect and extend. You can as far out as you want to extend. Make sure you get an arrow on that showing it would go on forever and ever and ever. Okay? That's all we had to do? Okay, part B. What total change in water level would you expect after 5 days? Ooh. Where would it be at 5 days? Because this is a constant rate, you could probably figure it out. And if you're like, I don't really want to figure it out and guess, I want to get it right on the test, easy. Put in 5 days and find out what you get out. Remember, you were supposed to be multiplying by 10 each time. So you would get out 50. Could you see that on your line? Yeah, if I were to keep going, it would have eventually hit that 50 point. I'm going to actually mark it. And I'm just going to say 5 days. So, explain your reasoning. Well, this is not that hard, but what would the total change in water level be? The total change would be 50, is it centimeters? Mm-hmm. Yeah, that's really odd to me because you don't usually measure liquid in centimeters. You'll learn that later, but usually it's a liquid measurement, not a distance. But I guess if you're measuring how tall it went, that would make sense. The total change would be 50 centimeters after 5 days. Explain my reasoning. Because it's going up by 10 each day. So because the level rises by 10 centimeters each day. And then I'm going to put in parentheses 5 times 10 equals 50. That's my reasoning. Oh, look at number 13. It's all of the yes or no's, yes or no's. And if you remember how easy it is to miss these, if you're going too fast, so we just go one at a time. It says, choose yes or no to indicate whether the first step in simplifying the expression is addition. Oh, that's pretty cool. Box this. All we're looking for is it addition? So we're going to write PEMDAS going down the side. Or right there in the middle, I mean.
You screwed it.
Yep, thank you. So we're looking for which one of these do you begin with addition. So you have to look at all the operations and decide, is addition the first one that's supposed to happen? It's either yes, it is, or no, it's not. So let's look at the first one, A. We have add, subtract, add. Will you put dots by those? Add, subtract, and then back to add. Would I do addition first in this problem? Remember, those two are connected. So is multiply and divide. So if they're connected, you work left to right. Which one was first on the left? Add or subtract? Add. So this one is yes. Addition would have been the first thing we do. Okay, next one. Is addition the first thing we do? Here, I'm going to erase my dots. I've got add, multiply, subtract. Add, multiply, subtract. Is addition the first thing I would do? No. Will you raise your hand and tell me what is the first thing I would do in this problem? Lots, a lot of people who know. Thank you. What is the first thing I would do in this problem? Number 16?
Multiply.
Yeah, it would be multiply. So this one is no. It's not add, it's multiply. I'm just going to write it too. I'm going to write multiply. That would be the first one to do. Okay, what about C? Oh, they forced me to do this one first. Did they force me to do addition first? Nope, so it's no. It is subtraction. That's what should have come first there. Technically, it was parentheses. Really? Right? That's kind of what forced me to do that. Next one. Where is it forcing me to do? What's it forcing me to do? Add. Yep. That one is forcing me to go straight to the addition. So this is how you need to look at parentheses. It's a force. Like the force field inside of it. It's forcing you to go there. You have to do that first. Okay, on 13E, are there any force fields? No. So then I have to look at my list and do dots. Okay. I've got a bunch of things happening on E. I have add, subtract, divide. Add, subtract, divide. Does addition come first out of all those things? No. What did come first? Divide. You just put the division sign. Division should have come first. I love this. Oh, wow. Lots of force fields happening. Remember, you start with the outside and you go, are there any more force fields inside of that? There are. What was being forced very first? Addition. Addition was being forced. I hope they ask this on the test because I think that's a pretty easy way. They didn't ask you to solve any of them. That's the best. What are they testing here in this situation? PEMDAS. They're checking to see if you know the order of operations. They don't care about adding and subtracting in this situation. They just want to know, do you know the right order? Got it? Got it. Turn to page 309. We're almost done. And there's only 2 problems on this entire page, so we really are almost done. Okay, number 14. Oh, there's a space for your name. Wow, by the time you're done with this, there will have been, I think you will have written your name, number, and date 6 times. You're welcome for that. You really better know the date. Stephen is flying his kite. He lets out 15 feet of string each minute. Will you underline that? That is the unit rate. Every minute it goes out 15 feet higher. Complete the table to show how much string he lets out for 1 minute, 2, and 3. This is how I know it goes in this table, is because these are the time in minutes, and that's the time they gave me. 1 minute, 2 minutes, 3 minutes. Then graph the data and connect the points. Does it say extend the line? No. If you extend the line and it didn't ask you to, you miss points. If you don't extend it and it did ask you to, you miss points. So just read. Make sure you're reading. Okay, so we already know in 1 minute he lets out 15 feet of string. You have to know that unit rate or you can't do the rest of these. So what is the relationship between 1 and 15? Am I adding 14 every time? No. Was 0 plus 14 0? No. What is the rule? How did I get from 1 to 15? I times by 15. So what's 2 times 15? It's 30. Circle it. That's a corresponding pair. What's 3 times 15? 45. Circle it. I now have all of my coordinate pairs to be able to graph it. This is on the test. Going from a story problem, you filling in the table, then you graphing it. Remember, you have to find the relationship before you can finish. Okay, 0, 0. Awesome. 1 minute, down here, 15 length of feet. So up to the 15. 2 to 30. And 3 to 45. And that's it. It did ask me to connect them, but it did not ask me to extend. So I simply connect. That is all I have to do. It doesn't ask me any other questions about that. Number 15, someone want to read about Tammy? She's measuring the total amounts of water. Thanks for reading about Tammy, number 17.
Tammy measured the total amount of water in liters that flows out of her sink and tub faucets. Each minute they are running. Describe two different relationships the graph displays.
Okay, interesting. We have two different things being graphed here. So she turns on her sink. Think about this in your bathroom for a minute. She turns on her sink and turns on her tub kind of at the same time. And she's finding out how much water comes out of each of those faucets. Will you just picture that for just a minute? Which is going to be releasing more water faster, a sink or a tub? Raise your hand. Think about that for a minute. What would take, what water comes out more and faster, sink or tub? Everybody? Tub, right? So you can tell that the tub is going up steeper. More water is coming out faster. That's called the constant rate of water dripping is much higher than it is in a sink. Okay, you can flood a bathroom a lot easier by a tub having problems than a sink having problems. So they start at 0 minutes. They're both at 0, 0. Obviously, if you don't turn them on, no water comes out, hopefully. So they're both off. Then after 1 minute, the sink has gone 10 liters. 10 liters. Just after a minute. That's crazy. Do you know how much 10 liters is? That's 5 of the big 2-liter things of pop or soda at the store. In 1 minute, out of a sink. 5 of those. So 10, yeah. So a tub was 15. So I'm just going to kind of show you this. So the sink was in 1 minute, it was 10. In 2 minutes, the sink was 20. You should write this on the side. In 3 minutes, the sink was 30. So what's the relationship, or what's happening with the sink? Every minute, it's putting out 10 liters of water for every minute. That is crazy. So when someone tells you don't leave the sink running, that's why. It's weird to think about that. I never think about how much water that is until you look at a graph like this. Okay, well, what's happening with the tub? Let's just go 1, 2, and 3 minutes for the tub. What's happening? In 1 minute, the tub was 15 liters. In 2, it was 30. And 3, it was 45. So for every minute, the tub is putting out 15 liters. And the sink was only putting out 10 liters. That makes sense. I would have thought the tub would be even more, almost double. But it's not double. You want to hear a cool number? It's 1.5 times as much. Or it's 150% of that. Okay? So, describe 2 different relationships that the graph displays. I created tables real quick to be able to talk about the relationships. Sometimes people can do it by just looking at the graph. I need numbers. I need to be able to see it. So, you can solve this either way. But what would one relationship be? Because it says, what is a relationship that the graph displays? Well, I would say one relationship is that the sink gets 10 liters each minute, and the tub gets 15 liters. That's how you abbreviate liters, it's just a capital L. And the tub gets 15 liters each minute. That's only one explanation of a relationship because I'm comparing in a minute. What's just another example that you, what's another thing that's happening? I would just use real 5th grade words. I would say something like, the tub is clearly flowing, more water is flowing out of the tub than the sink. Like that's another thing I could say. That's my second relationship. More water is flowing out of the tub than the sink. We did this a pretty interesting way. We gave more of the mathematical answer first, then we gave just an observation second. You can do that. Or you could have flipped it. You could have given just a simple observation. Wow, the tub is definitely having more water come through it. And then you could have given the mathematical explanation, but I think it's cool that we did both. Plus, it asked you to describe two different relationships. Is there another relationship that anyone can see or would be able to talk about? What would you say on this one? Number 4?
You could, make it so every 30 seconds.
Ah, yeah, I could split it and say, in 30 seconds, this one was giving out 5, and this one's giving out 7.5. Yeah, I could have done 30 seconds. I could have even said, yeah, I can tell that after 10 minutes, this amount of water would have come out of the sink. This amount of water would have come out of the tub. But I don't have to do that. I just have to describe two things that are happening. I think it's pretty cool. All right, turn the page to the last page, page 310. Oh, last place for your name, number, date. You might be asking, why does Ms. Fisher make us do this on every single page? It's because sometimes I only grade one page of it, and you don't know which page. So I don't want to have to flip through your packet to find your name. Let's put your name, number, date on there. Draw a line to match the computation in words to the correct expression. Ooh, this might be a little hard for us. Let's give it a try. Do you know who you need by a number?
Yeah,
Number 18. You're the lucky winner. Come on down. Thank you. Okay, multiply the sum of 3 and 5 by 2. Ooh, the sum of 3 and 5 have to happen first. That means they're going to be doing their some addition here. Then after I find the sum of 3 and 5, I multiply by 2. That's what I'm looking for. So which one of those shows it? Sum of 3 and 5. Oh, nope. This one's showing sum of 5 and 2. This one's showing not the sum of 3 and 5. Those aren't even connected. Is this one showing the sum of 3 and 5? Yep. And then do we multiply by 2? Yeah, that's the one. Wiki, and no, I'm not going to use that one again. So that's nice to know. Look at the next one. Add the product of 2 and 3 to 5. Product of 2 and 3 means those are going to be multiplied. Then I add 5. So I'm looking for a 2 times 3 and a plus 5. Look at the top one. Is that a 2 times 3 happening? Nope. Is the second one a 2 times 3 happening? No. It can't be this one. Is this one a 2 times 3 happening? Yes. And then did I add 5? Yes. So this is the one. Okay. Multiply 3, so it has to be a times by 3, by the sum of 5 and 2. So you have to add 5 and 2, multiply by 3. Add 5. I always have to go back because I get looking at the numbers and freak out a little. 5 and 2 have to be added together. Oh, that one is. 5 and 2 added. It's this one. And I'm not even going to check the last one. That's kind of how I would test take that. I mean, if you're really nervous about the test, you might just want to be like, okay, wait a minute. Add 3 to the product of 5 and 2. Yeah, so it's timesing 5 and 2. Add 3. It's a quick check. Awesome. Describe how to locate the ordered pair 6, 8 on a coordinate plane. Oh, they're not going to give you the graph. You have to say in words how you get to 6, 8. What do you think they're looking for? They're looking for you to use words like move to the right this many places, then move up. And if you wanted extra credit, you would use words like move along the x-axis 6 places, then move up the y-axis 8 times. See what I'm saying? Write your own explanation right here. begin at the origin, so that means you're going to have to tell them. Move to the right. Oh, and also if you just say go over, I don't know which direction you want me to go over. Be very clear. Begin at 0. Go to the right 6 places. Then go up 8 places. Whatever you want to say for that. You got your own description in 30 seconds. Someone want to share their explanation who's written all of it? I'll give you another 10 seconds. All right, what do you got for us? Number 11. What did you say? Loud and clear.
I said begin at the origin, then move it to the right 6 spaces on the x-axis, and then move up 8 spaces on the y-axis.
Love it. Way to go. You could say something at the end like, you will end at 6, 8. Or something like that. I don't know. Good job. All right, number 18. We're going to move on. This one's kind of fun. It's a plug it in. Evaluate each expression for n equals 8. Then classify the result as equal to 5, 10, or 20. That means if we get an answer that's not 5, 10, or 20, we did something wrong. Okay, that's pretty awesome actually to be able to check that. So don't panic. Just go one at a time. Solve it. N equals 8. So plug it in, plug it in. N is 8 every single time. I'm just going to go change all the n's right now to 8. Okay. Letter A, 48. Divide by 8 plus 4. What do we have to know in all of these problems again? PEMDAS. You have to know this. I think this and coordinate graphing were the 2 main things to get out of Unit 7. To know the order of operations and to know how to graph. Okay, here we go. So do I do divide or add? Divide. So 48 divided by 8 is 6, and 6 plus 4 is 10. Therefore, A belongs in the 10 box. See how we're going to do this? Okay, you can move ahead of me if you know what you're doing, but for the video and for people who want to stay with me, I'm going to talk out loud. B, you have to start in parentheses. 8 minus 3 is 5. Wiki. And 5 times 4 is 20. So B belongs in the 20 box. You will need to have work shown on your paper. So those of you who are moving ahead, don't do it all mentally. You have to show work. Okay, so we have to start here. 8 divided by 2 is 4. And 4 plus 1 is 5. So C is in the 5 box. I love this. This is so fun to me. Math is the best when it's like this. Okay, ooh, they don't tell me where to go. No force fields. Do I do multiply or subtract? Multiply. 3 times 8 is 24. 24 minus 4 is 20. D goes here. Next one. Ooh, no force fields. Divide, multiply. Uh-oh. They're connected. So you don't just do multiplication first. You do whichever one is on the left first. I'm going to do this then. 80 divided by 8, that's easy. That's 10. Oh no. 10 times 0.5, just think in your head. What's 10 times a half? Or what's half of 10? 5. What's the best? E. And F. Do I do add or divide? They're not connected, so it's divide. Ooh, 8 divided by a half. Here's what that means. I have 8 pieces of licorice. I'm going to divide them all into half-size pieces. How many half-size pieces would I have if I take 8 pieces of licorice and cut them all in half? This is mental math. It's 16. Dividing by a half is the same thing as timesing by 2, in case you didn't know that. If you can't do this in your head, you should have done this. 8 divided by a half. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip. And you would have gotten 16. But most of you in here now are at the point where you could go, okay, I have 8 licorice. I cut them all in half. How many half-size pieces do I have? 16. So 16 plus 4, 20. F belongs here. I hope this is on the test because I think those are pretty fun. And it forces you to make sure you don't get a wrong answer. Because if you ended with like 18, something went wrong. Had to be 5, 10, or 20. You know what's mean about these kinds of questions? If you didn't go in the right order, I bet some of them would equal one of these wrong answers. Let me give you an example. Let's try, I don't know which one would be a good, let's try C. Well, actually, I don't think that would work at all. Let's try one that doesn't have parentheses, like D. Let's say that I didn't do the multiplication first. Let's say I did the subtraction. So I did 8 minus 4, that was 4. Then I times that by 3, that's 12. Well, it can't be 12. It has to be one of these. So that was helpful. I'm trying to find one where maybe like you get the answer 5, but it was supposed to be 10. You know what I'm saying? I don't know if there's any that are like that right now on there. Which is nice, actually, that they did it that way for you. They weren't super mean. Okay, fine. They're not that mean to you. But when you get older, they'll do meaner things like that. Where it's like, okay, well, I think the answer's 20, but it actually was 10, but I still put it on 20 because that was one of the answers. So hopefully they don't do that on the test. Last one. Kind of odd to me that they end on number 19. Like usually tests end on 10 or 20. Number 19. Select the numbers that make the expression simplified to 36. What? That looks so weird. What they're saying is they just want you to create a problem. So I don't like looking at it like this. I would like to rewrite it. 60 minus. Then they have a bracket. And then it could be any of these numbers. 1, 2, 3, 4. So I don't know what that number is. I put like a blank line. Then I have a times sign. And then an inside bracket or an inside parentheses. That means I have to start here. 12 minus something. Close parentheses. Close bracket. Okay, don't panic. They want it to equal what? 36. That's really important to know because we have to kind of work backwards. Okay, let's just start plugging in some numbers. What if I used the 1 here? And I used the 1 here. Let's just see if that would work. I'm trying the ones. 12 minus 1 is 11. 1 times 11 would be 11. 60 minus 11 is 60 minus 11, 36. Nope. So it can't be the ones. But here's what I would do before you start checking every single number. I would first figure out, what do you need this inside bracket to be? Well, what do you mean, Ms. Fisher? I mean that once you find this number, you have to subtract it from 60 and get 36. So right now, you know 2 pretty strong things. You know that somehow you have to figure out how you got from 36 to 60. So quickly subtract those real quick and find out what the difference is. So that way you know, okay, I have to get, that's a 2, not a 1. 10 minus 6 is 4. I have to somehow in this bracket get that to be 24. Those of you who are pretty good with math, did you follow that? I went with what do I know for sure? I found the difference of that and went, okay, 60 minus 24 then needs to equal 36. So whatever happens in here has to equal 24 at the end. That actually is really helpful now. So now I go, okay, well 12 times, wait, is this a times or a subtract? It's a subtract. 12 minus something times by this has to equal 24. So what if I did 12 minus 2? That'd be 10. Can I get from 10 times something to get 24? No. 12 minus 4 would be an 8. Ah. And 8 times something does equal 24. So if I put a 4 in here, that would be 8. And 8 times 3 is 24. So this first blank line is a 3. This second blank line was a 4. It would have taken me a really long time if I just kept trying all these different combinations of numbers. So what was the best strategy? Write it out. Find the difference of what you know for sure and work backwards. Okay, I know this needs to be 24. So 12 minus something, and then I have to times that by something to get 24. We just guessed at that point, and it worked. Is this the only answer it could be? I don't know. I really don't know. What if we did 12 minus 3? That would give me 9. And 9 times something doesn't equal 24. I think it is the only one that would work. What about 12 minus 2? That's 10. 12. Yeah, it is the only one that would work. Okay, so that was nice. That wasn't like a million answers. Do you have anything to add to that? Yeah, number 4.
It's something about the number 18.
Okay.
There actually is one that
Okay,
answers
good.
you if you did it wrong.
Which one?
It's actually number E. If you start with multiplication, you actually do get 20.
Thank you. That's the thing I was looking for. Everybody look at E on number 18. I was trying to find a way that they were going to be mean and trick you really meanly, and this one would. If you did multiply before divide, you would have what's half of 8? 4. What's 4 divided by 80, or 80 divided by 4? 20. So if you did this in the wrong order, you would have put the letter E over here. And where does the letter E really belong? At 5. Thank you. You can get a stamp for catching that. I knew there would be one on there they did that with. Okay, that was fun. That was real fun. I hope you enjoyed it. Here's what you're going to do with the rest of your time. You are going to check. Actually, you don't have a lot of time, so you are lucky. This is the end of the math review. You don't have any math homework for this. But you do need to check Think Central to make sure all of your Unit 7 stuff is complete on Think Central. So, way to go with the review. Hope you're ready for the test.